All right, we're live. Welcome, everyone. Welcome to GraphQL FM. This is our second episode. Last week we had Dan Schaefer on. This week we have Scott Walkinshaw, staff software developer at Shopify. My name is Marc. I work at GitHub on the API team, and my co-host is always Tony Gitta. Hi, Tony. How are you doing?
Hey guys, I happen to be an engineer at Twitch who does API stuff.
So today we get Scott. Scott, you want to introduce yourself a bit?
Sure. I guess like both of you, we work on similar teams and positions. So I'm on the API patterns team at Shopify. Of course, this was a team that I met Marc on. We used to work together. Just over three? I don't even know timelines anymore, but somewhere like 3 years ago. Yeah, so I've been at Shopify for about 4.5 years now, and as part of the API patterns team for about 3.5 years. And we kind of a better name maybe like API foundations team. We kind of build API tooling, design patterns, documentation, best practices for not only GraphQL but all our APIs kind of Shopify wide, so that every team at Shopify can build better APIs and more easily contribute to them.
Awesome. Yeah, I think we all work on similar teams, so it's going to be cool to talk about the problems we face. So I guess my first question, Scott, can you kind of introduce us to what GraphQL looks like as a whole at Shopify? Like Shopify's this famous monolith. Is GraphQL part of that? Yeah, just kind of a general idea of how GraphQL looks like.
Sure. Yes. So if people don't know, Shopify is well known for being a large monolith application. Of course, like any company our size, even with that monolith, we still have lots of other applications, whether they're internal tooling, like Shopify apps that we build ourselves, or just other supporting applications. GraphQL is pretty much like ubiquitous at Shopify now. It's Shopify wide. We have basically deprecated REST internally. For people who use our REST APIs publicly, that doesn't have anything to do with that. Those are there and they stay, and we maintain and even build them. But for anyone building an API within Shopify, it is GraphQL first. And that starts with, of course, our main APIs, which are part of that monolith Shopify application. So our two primary APIs, which are also public, are the storefront API and the admin API. Admin's probably the much larger one. It's any sort of kind of CRUD operation you would do with Shopify, like any sort of store back office kind of management, as we call it. And of course, storefront is what a consumer browsing a shop. That's that kind of scoped API. So the storefront API has been public for maybe 3 years. The admin API went public maybe 2 years ago. So at this point, the GraphQL as a technology is quite mature at Shopify. I think it was originally added before my time, actually, maybe about 5 years ago. It started as a hack days project, which is a thing once a quarter, the whole company works on anything they want. And so it started from an experiment and it's grown from there. So, originally implemented by just a couple people for a hack days project. Now most developers will contribute to our GraphQL schema, whether it's our main one in the monolith or any other ones in other applications.
That's amazing. That's funny. With starting from something like a hack days project to being everywhere. Like, does that bring issues? Like a new developer starting at Shopify today, do they pretty much have to learn about GraphQL nowadays? And how does that look like? Is it tooling, education, all of that? Or?
Yeah, I mean, I guess if you are a front-end developer or a back-end developer, so if you're what we call, I guess, a Shopify UX developer or UI developer, you're obviously learning about consuming GraphQL as a client. And if you're a back-end developer, it is very likely that you will come across GraphQL pretty quickly within starting. Obviously, there's some more infrastructure or production engineering roles, or maybe some other backend ones that won't have exposure to it. But for the most part, people do need to learn it. And I think what's maybe more difficult than just like learning GraphQL as a general technology is is learning it kind of within our monolith. I'm sure you both have like, there's GraphQL, and then there's how you build it at a company and the specific tooling and best practices. I mean, I think it's similar to using like even a programming language or another framework. There's always nuances and differences. But like, I think a lot of the heavy lifting can be done by any sort of public documentation or resources that are available.
Yeah. So you have, it sounds very similar to Twitch, actually. Like we also, our GraphQL API came out of an experiment after we went to GraphQL Summit, and we're like, well, this seems like it could solve a bunch of our problems that we have with our REST API. Let's see what can happen. And then it just like took off from there. And also the same thing with the contribution model, where we have a bunch of client teams that consume it, but also like pretty much every like product feature team will make a contribution to our GraphQL API. I was wondering maybe if you could talk about like what your team's role is in kind of like tying all those pieces together. Like you mentioned, I think 2 different APIs, storefront and admin, and those are 2 separate, completely separate GraphQL APIs.
They're 2 separate APIs, like different endpoints. They're different schemas. Maybe the more interesting thing about them is they are like a lot of the types in them are the same name with common fields,
Okay.
but there's not too much, even like implemented in code, there's not much shared between them. So like, not to get too deep into it, but the storefront it's almost like a scope subset of the admin. So it's much smaller. And the context is a bit different, but a lot of the core types, like, in terms of Shopify, you're talking about e-commerce. So, there's things like a product or a collection and a checkout. So a lot of things like that exist in the same way in both schemas, but they are separate. And yeah, so I guess your question was about like, what kind of role does our team take?
Yeah.
It's quite broad. Like our scope is quite wide, which makes it a challenge in a good way. And maybe I can talk about a couple different aspects. So we do everything from, often we're brought in as like stakeholders at like a tech design phase. So if someone knows that they're going to be doing a larger change or contribution to the APIs, we're there to talk with them and maybe look over some proposed changes. Sometimes people do like some SDL, like schema definition language, as like just prototyping or proposing changes. Sometimes it's just more even talking at like a high level. And next we play a large role in people actually implementing it in code. So we have there's a term at Shopify, ATC, air traffic controller. Lots of teams have it. We have our own specific rotation for our team. So for say 2 days a week, we kind of we actively monitor changes to our schema. And no one needs our approval. We're not like gatekeepers, but we're there to keep an eye on things and make sure we see things from a high level, start identifying patterns as they come up. People have questions. We try and help out with that. So I think that's a big challenge for us, but just because of the volume, but it really maintains a level of like consistency that would be very hard to achieve otherwise. And then maybe the other large portion of our work is like features or products that we build ourselves that are more like API wide. Like I think we'll talk about it in a bit, but some of the caching we do, our big project over the past, 18 months was versioning our APIs, which we might talk about again. So that's because that's something that's like horizontal kind of across the whole, it's not specific to, like a domain. That's the responsibility of our team. Something I worked on last year is called bulk operations. It's a way of kind of like asynchronously fetching large data sets via GraphQL. So again, that's not something that's like domain specific. So that's the responsibility of our team. So we have a mixture of kind of like helping out other teams, but also developing our own features.
Nice.
Maybe let's.
Yeah, it sounds.
Sorry, go ahead, Tony.
Sorry. Yeah, that's kind of the role my team plays. It's we're involved in tech designs and high level conversations, but also at implementation time, like how do we ensure this data is being fetched efficiently, advising like how this new feature fits into the rest of the schema. Yeah, so it completely empathize with that. And it seems like not a very common approach for a lot of companies. So it's cool to hear you guys taking that same kind of approach to it.
Yeah, I guess anecdotally heard that a lot of people start that way and then quickly kind of give up like monitoring things, or especially if teams, if companies go to more microservices, then each team's kind of on their own. And at that point,
Yeah.
it's like you're obviously not monitoring every different team's microservice or schema that they're developing. Although I don't know how that manifests like once you start trying to like federate or stitch stuff back together. We've avoided that, so I have no idea how that works personally. So I'm curious about it, but I know like at GitHub, Marc, is it still more of like an active overview, or is it less so now?
It's still kind of an active overview. So our team tries to review anything that touches at least the public schema. So anything that goes through our public API, we still have kind of an API reviewers team. But I mean, it is kind of a hard problem. Like having kind of a gatekeeping team is hard to scale for us. So I've always kind of dreamt that like as a company grows, if you can find like kind of GraphQL nerds within the company who like really like it and they're in product teams, but they know how like to design schemas and they're really interested in it. And we have a couple of those at GitHub, those people, and it's so awesome when it happens where you don't need like an API team of gatekeepers anymore, and you just kind of have people who enjoy like being good at GraphQL in general, right? And I think we're kind of going to see more and more of that. A bit like if you have Rails,
Yeah.
for example, like there's no, it's
Yeah.
rare. Well, sometimes you do have a Rails team, but you have a lot of people that are just like very interested in building great Rails applications and great Rails code. Hopefully you
Right.
have that with GraphQL as well. So I don't know, Scott, like, do you feel the pressure on your team to like review and kind of being a gatekeeping team, or is that not too bad?
I don't. The pressure doesn't necessarily come from gatekeeping. The pressure comes from like sheer volume, and we have definitely done things over time to try and not only like reduce it, but as you said, we've done similar things where we care much more about public schema changes, because at that point there's really no going back. Um, so we have various tools and places that kind of help us manage that like workload. So prioritizing public changes definitely. Prioritizing like we even do like if a new type is introduced versus like changing like a field in an internal schema. So those are big ones. And but to your point, like we've definitely seen growth within the company of people who have gotten much better, and especially like once I think a very common pattern is a team needs to implement their domain in the API, and it's maybe up until recently, it's likely that none of them had experience designing GraphQL schemas. And then if it's a large feature, it can go on for a while, and by the end of it, they get quite good. And then if it comes up again, or if I've seen them help out other teams, so I find it really obvious when they go to do like, say, like a second type of feature or part of the API. So it's there's a lot more people. There's a much higher level of like general GraphQL knowledge than even 2-3 years ago.
That's really cool. That's really cool to see. I think one difference is like that I see with GitHub is since your usage of GraphQL is so widespread and it kind of seems like the only way to do things that
Yep.
it's kind of a not easier, but it makes more sense that everybody needs to get better at GraphQL and care about it. And I assume right now when teams want to expose a feature, it's kind of like one of the things they need to go through, right? Right. Even if it's a kind of a UI feature, do people generally have to
Yep.
write a GraphQL API for it?
At this point, our admin is almost done being redone in React, and I believe they still use Apollo client. So every UI feature is exposed to their GraphQL API. But that also started with the rewrite of our Shopify mobile apps, like native apps for Android and iOS. That was actually the like precursor that started GraphQL at Shopify, was those apps being rewritten, whatever, 4 or 5 years ago. So at one point it was just a mobile app like on Android and iOS that was like the main consumer of the API, especially before we made it public. And then our web client now is even bigger. So yeah, as you said, like every single feature that gets developed is going in there. And the really great thing about that for Shopify partners who build like third-party applications is they're getting the same schema and the same features that we do, that we're like dog fooding and actually using for ourselves. We're not just building an API that only third parties consume. Of course, we do have some internal only features, but if it is public, like we use it. So
That's sweet. That's awesome. Because at this point, like somebody wants something, a feature in the mobile app, and it's just no question that you're gonna get a GraphQL API, right? So maybe you mentioned versioning, and that's something we really want to talk about, because that's kind of something you don't see really elsewhere. And I think part of why is, first of all, there's not that many public APIs out there that are GraphQL. And also, if you go on literally like GraphQL.org, they're like, you don't need versioning, right? Which is funny for many reasons. But can you talk about what kind of triggered the need for versioning?
Yeah. Well, first of all, the trigger is nothing specific to GraphQL. I think that's the main thing that we realized is like every technology has different advantages and disadvantages, but I feel like there's some things that are more universal. And like we version everything in software. We version packages. Like everyone is very familiar with that. It's kind of an odd thing that you wouldn't do any sort of versioning for something as important as an API. So I think the trigger was that we had a REST API that was 10 plus years old that had slowly evolved, or in some cases like not evolved because we couldn't make proper changes, or we were scared of them. Probably scared because we likely made many breaking changes over those 10 years. And we had a large feature that was very, very painful for Shopify to migrate third-party apps to. I wasn't part of it, but like I think after that, everyone kind of realized that like we need to do something differently, and just kind of carrying on isn't going to be a good thing. And at that point, we already had GraphQL, so the versioning conversation, it had to be both. Like, so I think that was part of it. Is we still have our REST APIs that are public. We had to version that, and it would be weird not to version. I feel like it's inconsistent in that way. So now at least we're in a place where they're versioned conceptually in the same way. Of course, like the implementation of how we do it is differently, but like there's so to give you like maybe a very brief overview, we do time-based versions every quarter. It's like our next one will be 2020-10 in October 1st. And so when that comes out, there's a version for the storefront API, the admin GraphQL API, and the admin REST API. And you'll see like change logs for everyone, but it's the same versioning scheme. Of course, just how it's done under the hood is quite different.
But they're all synced, right?
Yeah, exactly. I think like storefront missed the first version, but now everyone's on the same schedule going forward. So,
how do you decide when to release a new version? So like to give a little background on how we do it at Twitch, we don't use versioning. We're very much ascribed to the no versions, because previous to this we had a new REST API version every 6 months, and that we had to create like a whole new. We had a lot more to maintain every 6 months because whatever breaking change would come up. So something that we didn't have to do that seemed pretty appealing, and we'll deploy maybe I don't know, up to 20 times a day with changes, and typically they're not breaking changes. Sometimes they have to be, but and this is an internal only API, so we're not supporting it publicly. But maybe you can talk a little bit about how you decide all right, this is what's going in this new version, and like that kind of planning.
Yeah. So I'll give some more high level details, and I think that will kind of answer those questions. Is first of all, when to version. Now there's a large discussion at the start around the schedule for it, but now that it's in place, I mean, it's automatic. It's happening every quarter. So and that is basically just the roll up of changes that we've kind of accumulated within that past time period. Now that part's not automatic, which is a bit more interesting. So obviously at Shopify, we have a lot of teams, a lot of developers constantly contributing and developing, adding to our API, sometimes breaking or changing it. And we have a system in place where basically like an API version is actually just like a roll-up of what we call API changes. So people are constantly defining these API changes, which are much like smaller units of change. And they constantly define those and implement them in code. And that gets exposed in our like unstable API. So the unstable API is always available. In fact, people can use it publicly. We just tell them like, we can break this anytime, so don't rely on it. So the changes go in there. And then basically, so I'll take the example of for October 1st, our 2020-10 API version. People need to decide that, okay, our feature has been like tested. We've maybe had beta partners, it's stable. And then they kind of attach it to that next version. And then so when that day comes around, then we have a list of all the changes that are included. And, we have things like change logs and migrations and documentation on that. So I think having like the consistent schedule, like that just rolls on. It's never going to really stop or change. And it's kind of up to teams to self-manage if they are confident that, they've done enough due diligence and research and iteration that their change is now going into a stable one. Because like once it's in a stable one, of course, we never want to make breaking changes.
Do you ever like have issues with, because there's kind of this famous problem sometimes with previews or like unstable branches where teams will just never hop on the next train and just kind of constantly stay in preview mode. Do you kind of have a way to push teams to like release them in stable versions, or is that just not even a problem?
I don't actually think it's been too much of a problem in practice. I don't think it's implemented. We've had like an issue in like our backlog that we have what we do have, we also have release candidates versions. So that's just like the next one so the release candidate right now is 2020-10 because it's not October 1st yet. So we do have a process in place via like some Slack bots where it messages teams if it's getting close to like that release time and their change is still in there. And we know that we want, in addition, we've logged it, that we want to message teams when the change has been in unstable for too long. But I haven't heard of it being an issue yet, thankfully. I think there's an interesting, like, I guess like psychology that teams want to get their changes in a stable version. Because like if you're developing a feature, you probably want it consumed by third parties. It feels good for someone to use something that you've worked hard doing. And because we really encourage our partners to use the stable versions, they're not really going to use it if it's just an unstable. So I think it kind of works. It's kind of a self-encouraging loop there.
Yeah, it's almost kind of a cultural thing where people really want to expose their APIs. That's awesome. So maybe we can go into the juicy details on how that versioning works, because you mentioned you have a storefront and admin APIs, and you did mention they didn't have much in common, even code-wise. Now with versioning, you're kind of adding a multiplier on both these versions. So how are you managing that in code? I think you're using kind of a code-first approach, right?
Yeah, we haven't talked too much about this, so maybe I'll give a brief overview as well. That Shopify is well known for not only being a monolith, but using Ruby on Rails, which of course means we use Ruby. So we are using the GraphQL Ruby gem. It's the canonical GraphQL server implementation. And built into that gem is a feature called visibility. I think I listened to some of the show last week. I think it came up with it.
It might have.
Did it? But I forget. But anyway, I'll describe it a bit because I don't know if it really exists. Do you know if it exists in other language implementations?
It's very rare. It doesn't exist in the JS world for now, which is, I think a lot of people don't know about it.
Yeah, so and I guess that's the consequence of most of the JavaScript GraphQL implementations being more like SDL first instead of code first. So yeah, visibility is a concept. I mean, in one sense, it's simple. It's just, is this a schema member, like type or field or argument, visible in the actual schema? So you can define it in code and then kind of dynamically control whether it's actually visible to a consumer of the schema. So like a really like classic one is just having like an internal flag. And so you can, in code, you just say visible, like internal. and then any public client can't see it. So that's kind of how visibility first started at Shopify, very like broad, just like internal or public approach, basically. And then when we were implementing versioning, we pretty much like the only option available was visibility. So it's kind of interesting is, so again, using example, like our next version coming out, 2020-10, it's like certain schema members will now just become visible in that version that previously weren't. So it's using the visibility feature that the gem provides with a large, more specific like API versioning layer that is obviously custom to Shopify and specific to our needs. And Mark, you asked like how does that work with different schemas? I mean, it's just implemented each time twice. Like the changes are independent. So sometimes someone might define a change that affects multiple schemas. So it would just be storefront and admin. Those are the only two options. But like to actually implement, say, like a new field, if there was a new common field on, say, the product type, it would have to be implemented like twice in each one. So, but I mean, the storefront schema does evolve a little more slowly. It's like I said, it's much slower. It's stable. It honestly may be a tenth the size of the admin schema. So yeah, it's just a much smaller scope down schema. And in reality, I don't think it's I mean, there's different issues that come from managing that, but I don't think versioning has really been one of them, thankfully.
Nice. Somebody asked a really cool question in chat. Every combination ask if the changes between versions, are they just about schemas, like in Combado schemas, or do you actually have like logic change in there as well?
Yeah, that is a good question. So largely they're schema members, and that is kind of built into our kind of GraphQL layer on top of the gem, is we can easily, attach an API change to a specific schema member. Usually it's usually at the type level, and then the field kind of inherits it too. But we definitely do have like logic, or we just call them like behavior changes. And so like to give a GraphQL example, if you are changing the way a resolver works, we do have some cases where there's just a conditional branch like within a resolver. It would like literally, I'm trying to say this in code, it just says like, if this API change is in effect, that's what we call it, kind of like enabled, then do this, otherwise do the other logic. So there are some of those. Sometimes it's like there's maybe a bad bug in a resolver, and sometimes we say that's just like correcting the contract, so it's not necessarily versioned. But any sort of like different, like actual different logic, or that's like new behavior, we definitely do version those as well.
Nice.
Does that get hard to manage? Like I imagine like you can have a lot of different versions of behavior in the worst case.
I'll let you know in maybe like 2 years. I'm sure. I think that the point right now is like we haven't had too much. You can get like nesting basically, right? Or like much more complex conditional branches. We just haven't got to that point yet. Right now, it's largely just like one top level one. So I think that if that does happen, it definitely will be complicated. I mean, like versioning is complicated. There's no getting around that, by the way. Like it does put more of a burden on every developer at Shopify, but we think that it's outweighed by the benefit for any external consumer with like the kind of trust and guarantees that come from that. And it's also one of those things where everyone thinks that it's just like bad, like it's just annoying, but there is a benefit for us as well, because there's changes that like we never had the confidence to make, or we couldn't safely make before. So it's like a weird catch-22 that people think it slows down development. It's like, oh, well, you can only release a new feature every 3 months, but there are things that are possible with it that like really wouldn't be without it. So it's kind of an interesting catch-22. It's a give and take.
Yeah, it's just the trade-off you picked, and I think the public API makes that even more worthwhile, because like Tony, with like an internal API, like you can go like fully like additive changes and like go off
Jira tickets for everyone,
like go off a completely different branch, and then eventually you'll catch like every client, and tell them they're deprecated.
Yeah.
You can annoy them for like years. With a public API, you've got like hundreds of thousands of people. You don't even know how they're using your fields.
Or you
Yeah.
can do some nice like brownouts like GitHub does. I always like that idea.
Yeah, brownouts are cool if you do them well. Yeah.
Yeah. We did that for our old REST APIs actually.
Mhm.
So it's kind of like we're kind of all in on GraphQL for our first party stuff and trying to move our to like our official third party API for all the REST stuff. And browning out was a great way to make sure like everyone kind of knows about the schedule, they're informed of it, and they have enough time to like get off of it without just like shutting it off. It's not a bad idea.
No,
But
we've never done it, but we've actually wondered like there's definitely some like some third-party applications that would just never even notice like that they're erroring for 4 hours. So it's actually
Yeah.
interesting. Like obviously the good ones, you have monitoring in place. It's a really actively used application. Of course, they're probably going to notice, but I always have this fear that people would just not even notice a brownout.
Yeah. Yeah, sometimes you get hobby developers who maybe do it like in their off time and yeah.
Yeah, that's another thing. It's very hard to make the difference between like kind of a zombie app, just like that wouldn't really be broken because it's somebody forgot about it, and something really critical. Like you can kind of know who your biggest integrators are, but then beyond
Yeah.
that, like it's hard to tell sometimes. So more again, going back to like the technical side of it, you said like if API change is enabled or something, these API changes, are they more granular than versions, or they're literally kind of one version?
No, they're way more
Okay.
granular. So like an API change it could be as small as a tiny logic change in a single resolver. It could be often they more correspond to like a new project. Like if someone's adding like a new discount system, like that might be one change that then gets introduced in a version. So yeah, every version we roll up all of the API changes that are basically attached to that version. And it could be anywhere from I don't actually have numbers. It could be 10, it could be 30. It really depends, and the size of them varies. But basically, when developers are like contributing or adding to the schema or just changing it in any way, they think about at the API change level. They don't really care about like the versioning itself. They only care about that when it comes time to like finally release it like publicly, and then they say, okay, it's ready. This change is done. We'll attach it to this next version.
That's really cool. So it's very similar to like Stripe's declarative change idea
Yeah.
thing, but then for Stripe, I think their version are more like kind of, they're not as set in stone. Like it's as soon as they get a breaking change, now you've got a header, you can go there. But for you kind of mix and matched like windows, but then these contain declarative changes. That's cool.
Yeah, I've never seen. I know of Stripe's like strategy. I've never seen anything about their implementation, but ours definitely took some inspiration from thinking at a more smaller granular level instead of just like here's a new version. So yeah, it's more like really the important thing to a developer and us is the API change, not necessarily the version. The version is almost like it's just a side effect, basically. Like if everything's done well with the changes, you're just like, okay, well, here's a version that has all these changes, and that's it.
Sweet. Somebody asked a question. Nimster asks, okay, so do you take into account queried GraphQL fields to optimize your like SQL queries? So it's the whole like taking a GraphQL query and trying to kind of optimize ahead of time the SQL queries. Do you do any of that?
Yeah. I imagine that's asking like, yeah, if we are looking at the like subfield selected. We don't yet, and there's probably a couple reasons for that. I mean, we definitely take advantage of in the Ruby world, batch loading and JavaScript like data loader. Obviously, like that's a must, obviously, to get rid of n+1 queries. That's kind of the level of optimization that we're kind of at. It might be a benefit to try and go further than that, but we haven't really found it yet. One reason is Shopify has it's actually a public gem called Identity Cache. So if you picture your active record models that are usually coming from a SQL database, they get cached in Memcache. And because there's that intermediate layer, often we're loading things from Memcache into the database. So the same optimizations don't really apply. Like, it's changing like a select star to select some specific fields with joins. But if we're already fetching them from Memcache, then it kind of gets rid of that option.
That's true. And I assume, like, at least for us, I can hardly imagine that kind of stuff working at GitHub, because our GraphQL layer, when you receive a query, I feel like it's very hard to know what data it's going to end up needing. Like, we have a ton of complex business logic, tons of conditionals.
Yeah.
It's very hard to know ahead of time like what you're exactly going to need. So the batch loader approach is nice for that, because you just kind of accumulate things lazily.
Yeah. I think the other issue is, and I know, Marc, you talk about this a lot, and I'm glad you do, that like your GraphQL schema isn't a mirror of your database. You're not just exposing your database. And a lot of people, when they have that, like, there's tools now that just automatically expose your database. That's very easy to do those optimizations where you change like some end queries, or even in the select star to fields with joins. But if you're calling, if a resolver calls like a function on a model that is derived from like 4 other underlying fields, it's almost like, I'm not gonna say impossible, but it's really like diminishing returns to try and do stuff like that, because it won't apply in many cases.
Yeah, I think diminishing returns is a good way to put it. Like, you could probably shave, a few nanoseconds or milliseconds, depending on like how fast your network is, but is it really worth it? Probably not. Like, I think it can get really a lot to keep in your head of like what gets what. Like, why didn't I get this? Or like, I'm pretty sure you could do a PhD project on like how to optimize a SQL query from a GraphQL query, especially like when the results of something are so contextual based on like if I ask for your friends on Twitch, I'm not allowed to see those, so I wouldn't have anything to optimize there, but I wouldn't know that until I do that check.
Yes.
Yeah,
exactly. Sorry, go ahead, Marc.
Just Nimster, the person who has the question, says that makes sense, and the optimization only makes sense in your case when it's not cached and when it's not too complex. And yeah, I agree. I feel like these auto SQL things only work in the base case. Like, generally they either do your schema is exactly your database, which then kind of makes that easy to transform into SQL. If it doesn't map exactly, you'll have like annotations on your GraphQL schema that says like this loads this field. That's like seems unmaintainable if I think of like Shopify's code base or GitHub's code base. And then the only other option I see is like something that you would write a paper for years about, where like statically analyze or something. So
yeah, you're right. I couldn't imagine the annotation approach being like scalable at all. These things are already difficult, and when you start adding those like layers on top, it gets really hard to like keep in your head.
Yeah. Since you talked about caching, and you gave this sweet talk on how you cache things, do you wanna switch to that subject?
Yeah, let's do it. It's I can only talk about versioning for so long anyway.
Yeah. Yeah, versioning takes a toll on everyone.
Oh yeah.
So yeah. In your talk, you talked about how you did caching, and maybe like caching is hard in general, like in software. In REST, it's hard as well, and in GraphQL, it's, I guess, especially hard because it's rare you get like very similar queries, the exact same shape. But you found a very, very interesting way to make it work. And yeah, we want to hear about it. Do you want to explain a bit how it works?
Yeah. So yeah, first of all, we've had a full query cache system in place on our storefront API for at least a year and a half now. And I think that's even probably a little more unique, as you mentioned. Then usually with GraphQL, people are caching a single field. Like maybe it's just a time to live on a single resolver. I know there's some Apollo features where you can like tag certain fields as cacheable, and maybe some gateway, upstream takes care of it. Our approach, as I mentioned, was a full query cache. And I think the difference there, what makes GraphQL a bit more complex to do that in, is we only had certain parts of our schema that we deemed like cacheable. And that's the hard part, because of course any public client can send a free form query, and we don't do persisted queries. It's completely open. You can just submit your GraphQL query document or just document. So what we do is we basically in code, we opt in types to our caching system. We say if this type's cacheable or not. So example, product is cacheable, collection is cacheable. It's often that kind of like merchandising type data that is cacheable. And so when the document comes in, we statically analyze it and we collect every single type referenced in the document. And only if every single type referenced is cacheable, then we go through the cache for it. And I think another thing that makes GraphQL a little harder is like computing the cache key. You have to include a lot of different pieces in there, which really makes like the cardinality like very high. As you mentioned, like we get any minor document variation is like a new cache key. So we have still found though that we get enough cache hits to make this very worthwhile, especially in the case when you have a client that gets a lot of traffic, say like a native mobile app that has a Shopify storefront and it uses the storefront API. If 1,000 people go there, that native app, it's one query, right? Maybe the variables are slightly different, but there's still enough commonalities in these queries that our cache hit rate is useful. So of course you have to include things like whether the query is valid or not. We do like a hash of the document, things about variables, and then it has to tie into our own caching layer. So it's kind of funny when I did that talk, I thought the interesting part was like the GraphQL side, but all anyone wanted to ask about was like, well, how do you actually like bust this cache, and what's your cache system like? And I hated giving this answer, but it's true. It's like, well, it just entirely depends on your own application. Like we already had one in place at Shopify, which is what actually made this even possible. It's like the GraphQL layer is very interesting, but like in a way, the harder part is managing like your cache and how do you bust stuff and how long is it stored. If you have data that's able to be like a time to live, that's like best case scenario, because then you can just say, oh, it's cached for 30 seconds, and that's great. If not, it's obviously much more complicated. So it's really like it's like marrying like this existing cache system that had been in place at Shopify, like at the database kind of level, and with the more GraphQL specific query cache.
Do you guys kick that out to the CDN at all, or is that purely like in-app?
Purely in-app, partly because there's just a lot of dynamic stuff going on. Like we need to statically analyze things and generate the whole cache key. Maybe it'd be possible. I don't know, but it's good enough that it really takes enough load off our API servers.
Mm-hmm. Yeah, because I kind of assume like most of the cost of a GraphQL query comes from like loading everything. Like if you skip loading from Memcache and MySQL, you've already like gained a ton. Like it's not necessarily. I mean, a CDN would be great, but you've saved a ton, I bet.
Exactly. Yeah. I mean, for large documents, validation can be high. Not necessarily parsing, but like query validation can be high. And honestly, I'm actually forgetting off the top of my head if we skip it or not. Well, if a query, we only cache a valid query. Okay. So technically at that point we could skip validation. I honestly think we do, but so there's certain costs like that. But yeah, you're right. Is like the majority of the costs, especially if they're loading like a lot of data, is obviously going to various data stores. Like we're not running any resolver for any field when it's a cache hit. So that's the biggest game.
Mm-hmm. Sorry, you're hearing my cat right now. Do you use persistent queries like internally?
No, we it's always been on our list of things to do. We think it would have nice benefits of identifying. It would open up more opportunities for like more unique caching or maybe skipping validation, things like that. But yeah, we still don't even do it internally. I think even internally more than externally would be a nice thing, probably for like our like native clients. Have like a set of known things, and it would save them like bytes over the wire, and it would definitely be a little faster. So it's on our rough roadmap, but it's never been a priority.
Yeah. We implemented this at Twitch, and I don't know that 100% of our clients are bought into it, but we implemented it as kind of a way to control like query complexity growth. So as we started doing more and more sophisticated things, we just had these huge queries that we had to send over the wire, and we're not very like well globally distributed, and we have users all over the world. So when we turned it on, it saved like 20% latency for us.
Wow.
So it was actually pretty impactful.
Is that from? Do you think that's more so from things like sipping validation and parsing, or is it more like just the bytes over the wire?
I think it's the bytes over the wire. Like the parsing and validation, I don't even know. So we have a Go-based server,
Okay.
and it runs pretty fast. Like I don't know if it takes more than a millisecond to do those steps. But the bytes over wire is pretty expensive. Like just network is hard.
Yeah. Yeah, it's interesting. I mean, like parsing. Yeah, I mean, obviously Ruby's generally slower than Go. Parsing is almost always very, very fast. There's definitely some validations that can get quite slow depending. Like, I mean, people can send insane documents, like with like recursion and stuff. So sometimes the validation costs can be high, but for most of them, it's negligible. Yeah.
We've definitely had performance issues with parsing and analyzing and validating queries before. And those were actually mainly internal queries for a while. We were building these huge queries, and so GraphQL Ruby has this analyzer API, which is basically a validator. But yeah, just going through the AST of a large query and running things, sometimes it's pretty surprising. But then again, yeah, we're Ruby as well, so I'm sure it's a little bit slower than what you're seeing, Tony. But yeah, you got to be careful. I think for a while we just assumed internal queries we validated once, like at CI and in development. So we skipped validation and don't think parsing always, but certain things we could do, and huge difference for sure. Yeah.
It seems like a really nice optimization.
I think when you can do that, it's pretty cool. And I think, but the bytes over the wire thing is impressive to me. I always kind of didn't think of that much. I mean, it makes sense, but that's cool to hear.
Yeah, it was definitely not like I think globally it was more like 8% improvement, but you have some areas that have pretty poor connection, and it makes like an outsized difference for those.
That makes sense.
Yeah, and I mean, I never think about it that much, but like that is a large difference between REST and GraphQL. Other than like, say, like a post endpoint, like creating, say, an operation in REST. Like, of course, you might have a large post body, but generally, like for gets, like that, the request is way smaller on average. You know, unless you have some like GraphQL type query language and query params and REST, but even then, it's not going to come anywhere close to like a large, complicated document.
Right.
Yeah, that's kind of the beauty, because like GraphQL, I guess, like your responses are in theory smaller than REST. Not always, but that's the in theory. But then your request was larger, so I guess the what's so cool about persistent query is you come back to like a small request body and hopefully a smaller response body as well. So that's cool.
Sorry, my AirPods are dying. I'm gonna switch over really quickly.
No worries, take your time. Tony and I will talk about caching still.
Yeah, we have caching, but it's not beyond like persistent queries. We don't have a very sophisticated like caching of GraphQL itself. It's more like the underlying data that is cached. And I think that's more due to like Scott mentioned this, but kind of like, I think depends extremely on your use case. So like Twitch is like a very live platform with a lot of things mutating and a lot of contextual fields. So I think like caching could be interesting, but it's not been like a huge high priority thing, because I think we'd have a super low hit rate. for like the specific caches as well. Or we'd have like a massive key space that I don't know exactly how you manage.
Right.
It'd be
That's
impressive.
the only.
I was gonna say, sorry, it's funny you mentioned that like we were really worried about like just cache key explosion, and
Yeah.
I apparently the memcache instances we have are just like beasts because like it didn't even make a blip. Like I was shocked,
Nice.
and I think that comes
Nice.
from I mentioned our identity cache thing before. Is we had
Okay.
such an infrastructure in place to manage this that the volume just wasn't a big deal.
Nice.
That's the whole thing about caching GraphQL too is that I find people like think it's much more important than it is for certain products. Like it depends, right? But for GitHub, if you think of like issues, pull requests, like any Git metadata, we can't really tolerate that much staleness, right? Like in the first place, even on the UI or even with REST before GraphQL. So like even if we wanted to cache things, it would need to be like stuff that's much more static. So like I've seen like a countries GraphQL API somewhere, just like a list of countries. Well, that's easy to cache with GraphQL, but then why are you even using GraphQL at this point even? So like it's kind of overblown sometimes.
Yeah.
And I mean, when you have a use case for it, like the storefront, for example, and you already have a mechanism behind the scene, like the shop version thing that's already used on the front end and maybe even in REST before, like that makes sense. But then it's not,
Yeah.
it really depends if you want to cache in the first place.
We found a couple of times where like the vast majority of our data is super live and we can't really tolerate staleness, but there's some things like maybe like layout parameters or like different groupings of things that are fairly static where we want to experiment with them. And it doesn't have a super great fit into the system where we've decided like we're going to favor liveness. And it's a little bit awkward to figure out where to put those kinds of things. I don't know if you guys have had similar.
Oops, I think you're muted, Scott.
Oh, sorry. I was going to say, other than our storefront query caches, other than like we do the same thing in the admin, is like certain resolvers may implement their own specific caches, of course, like they're free to use like memcache or register stuff. And then there's that identity cache layer. But it's interesting, like I think me and Marc have both talked about this before, that people seem to like focus on what's not possible in GraphQL compared to REST, even though that almost never happens in practice with REST anyway. Like they talk about the lack of HTTP caching, but most REST APIs, in my experience, and anyone's feel free to correct me if they have their own different experiences, but most of them are still hitting the application server. They're not doing full like 304s or whatever. So by the time you get to the application server, you have to do often database lookups to figure out if something's cacheable anyway. So like at that point, you're back regardless of REST or GraphQL, you're back to relying on the same sort of caching solutions.
Yeah, that's true.
Right.
Like computing kind of an E tag or like last modified for a REST resource, depending on how you've designed your stuff, it can be just like a created attribute. But if you're going more on the GraphQL side with like more dynamic responses or like compound document, then it gets like really hard to compute cache keys as well. So yeah, I always say like what's hard, like caching dynamic things is hard, but GraphQL is super dynamic, but you can have other APIs that choose to go that route in general. So it's not like an inherent thing about GraphQL, right?
Yeah, I mean, I think what I often tell people with GraphQL is like many things are more complicated and just harder. Also because it's like different and new. But I often don't like people just saying like GraphQL is better than REST. Like it is trade-offs. Things are harder. It just has more. I'm not even gonna say advantages. It just has more like opportunities that you probably don't have in REST because you have like the schema and type system and stuff like that. Like, so I feel like it unlocks more things, especially with like tooling, which really helps.
Yeah, it's kind of this. I've always thought of it as like this big shift from complexity on the client side to stuffing it in the server, and then at least that gives you a big lever to use where you can, figure that out, and hopefully you have lots of clients that then can take advantage of that.
Yeah, almost everyone that like really loves GraphQL you like, oh, how have you used it? And like, oh, I've been, querying an API on the client. And of course that makes sense because like that experience is like really good. And yeah, then the flip side is like someone has to implement that complicated GraphQL schema on the server. And I think all three of us have a lot of experience with that. And like there are more challenges, but I don't know, it's fun too.
Yep, if it makes sense for the client, it's like versioning. Like if you want to take on that complexity because it helps the clients in the end, like you choose whatever it's worth it or not. So maybe before we let you go on the subject of the public APIs in general, I think when people hear public API and GraphQL, they kind of freak out, and like in terms of like security and rate limiting and everything. So maybe at GitHub we have like that complexity approach where we compute kind of a score for your query and we try to rate limit you and block you based on that. Are you using something like that at Shopify or?
Yeah, it's I guess quite similar to GitHub's, but different. We do calculate a cost, as we call it, and that metric is both used for rate limiting and as like a static max limit. So we calculate a score, which generally corresponds to like the complexity of the document. And so like I think publicly right now it's 1,000 is like the static limit. So yeah, any query comes in, we analyze it. If the cost is above 1,000, it gets rejected right away. If it's under 1,000, it gets executed, and that cost is kind of taken out of your bucket. We use like a leaky bucket system for rate limiting. And I mean, I think that's one of the most challenging things. Actually, speaking of like things that are harder in GraphQL compared to REST, is anything to do with rate limiting and trying to control which documents are allowed or not. As we've learned, there's many kind of like loopholes or documents that you may not think are complex, but really are. And then there's complexity is also tied to like your actual schema, right? Like there's some GraphQL queries you can just put 10,000 fields and it's probably going to be complex for anyone. And then there's some that's like, oh, I called one field and this thing takes 10 seconds to resolve. Hopefully we don't have any fields that take 10 seconds to resolve, but I don't know. There's slow, there's slower ones, or mutations, of course, like often are slower. So we still largely have like a general algorithm with the option to set specific values for fields or mutate or fields. But in reality, we haven't really tuned things other than the defaults. One, it's really hard to, like if you figure out some field is slow and you're like, oh, okay, this would actually have a cost of 100 instead of 1, for example, that can like break a client right there, because if they're calling it, it can push them over that 1,000 static max, and then all of a sudden their query goes from being accepted and executed to just rejected up front, and that's a breaking change. And I think just like the overhead of like trying to keep in your head as as people who implement the schema of like how to tune something and what value. So we've largely just kept the algorithm without like overrides.
That's a really good point about the breaking change. Like it becomes your contract at some point, and then you're stuck. I guess like a good advice would probably be, if people want to implement that, is starting like really restrictive and then getting less restrictive as you go on, because you can't really go the other way around.
That's exactly what we've done. Like I think one maybe common criticism of our APIs publicly is that like in GraphQL the limit and the rate limits are kind of low, and that's because we knew that it's way easier to relax it than to go back. Like you basically can't go back.
Right.
So I think we've probably gathered enough evidence that we probably could safely raise them a bit. But at the same time, clearly like people have been able to accomplish their usual like kind of whatever workloads without much issue. So I think we actually hit some pretty good numbers originally, and we probably could raise it a bit, but we haven't yet.
Nice. So one problem I see often with these approaches is where we've faced that quite a bit lately is, so we have that max limit, like you said, like 1,000. If it's above that, you block a query. But then you also so I assume you kind of have a timeout, like a limit of time a query can take.
Yep.
And sometimes it's surprising. Some queries will go under the complexity limit, but still end up taking a long time and like hitting timeouts. And then, so like ideally, in an ideal world, any query that will timeout is blocked right away through like the complexity cost. But it's been really hard for us to find the right balance for that. Sometimes it depends on like how much data like a repo has. I assume like if a shop has a ton of products, the field costs a little different.
Yeah, it's I'm not gonna say it's impossible, but I think it's like it's one of those things you'd have to write like a paper on it and get like so
Yes.
complex that again like whatever, I don't even know if it's 80%. Let's say like the 70% solution is probably like more worthwhile. We've thought so many times about like rethinking various strategies, and every time you go down one path, you realize that it's just a different set of trade-offs, and like I don't know what the correct set is yet.
Right. Yeah. Speaking of which, we're trying really hard to get Eric Wittern. He works at like IBM Research, and they wrote a paper on like complexity of graphical queries. So we really want to have him on, but that kind of gives you an idea, I guess, of the complexity of that problem, which is like really hard.
Yeah, yeah, because there's just the complexity of GraphQL itself, but then I said like, or as you mentioned, even like it's not even anything that's deterministic. Like you could have a database issue, so something takes longer than usual. Yeah, depending on the volume on a specific shop, like it can have a different, maybe your database picks a different index sometime. Like there's so many things that can like drastically change like the time taken for a specific query or mutation. So it's really hard. Yeah.
Tony, do you have any kind of rate limiting? I assume you have some sort of rate limiting at some layer for like internal apps, but do you have anything like GraphQL specific?
Specific at GraphQL, it's kind of like we take like a macro and micro approach. So at GraphQL, we look at the amount of time something takes as a good as like a heuristic for how expensive it is, because we're not backed by like a couple data stores or something. We're backed by like hundreds of services that then have data stores, and they can all have different problems, or networks can go away, they can slow down. So it's hard to figure out the cost at the GraphQL layer in front of everything else. So we try to push those micro decisions down to the services themselves. Because GraphQL is not even the only API we have. We have other APIs that also request the same data from those services, and those rates need to be. What we're trying to protect is those services. So we push those in the back, and then at the front we have more like how long is this taking? What's the depth of the query? Just more in that vein of like this is the high level stuff that we'll just stop right away. But yeah, and other than that, we try to keep our times pretty quick and not really variant. So this has been a little bit painful when we have some slower operation that we need to, some slower synchronous operation that we need to introduce. Kind of have to like rethink if it should be synchronous. Maybe we break it up into an asynchronous operation just to keep things moving fast and timeouts low. So it's definitely like that's a very simplistic approach, I think, but it's not without its trade-offs.
Yeah, that makes sense.
But I think it's useful though I think there's another point where it's useful to think about like REST compared to GraphQL, because Shopify has always had rate limiting for our REST APIs, and again, it was like a leaky bucket, and we always costed like one request is one basically. So like you can do like 2 requests per second, but if you think of the different costs to execute any specific like endpoint, they drastically differ. Like again, if you're creating a product that has a bunch of like nested data attached versus fetching one product or fetching a collection that has 100 nested products, like those are all costed the same. And that's actually not like, that's pretty common for REST APIs when that rate limiting is like they don't treat any endpoints differently. And so working on GraphQL has kind of made me realize that a lot of these problems that seem specific to GraphQL actually exist in REST. They just aren't like exposed as much, so you don't often think about them. So like then we started thinking, oh, or actually, we actually had a way in our REST API to tune the cost of each action, and no one has ever said it differently in 10 years. So like that, it's another thing that it's just like these same problems that you just kind of keep like experiencing or reinventing or forget existed. So yeah, like people keep talking like, oh, how do you do this with GraphQL? And sometimes I'm like, well, how do you do it with REST? You know?
It seems like with REST or like any other HTTP API, those problems are just for most people just under the limit where you need to start caring about them. So it seems like they're not existent, and then GraphQL pushes them over where you like actually need to say something. But that's so true. Like there's other APIs, like I think the Slack API has different tiers depending on the endpoint, and like each tier has a different burst and how many requests you can do per minute. And that makes a ton of sense. As you said, like there's endpoints that are more expensive than others, that's for sure. So that's very interesting. Somebody in the chat asks, every combination, how would persisted queries play into rate limit, especially with a public API? And it asks if persisted queries are a thing for third-party APIs. And that's really interesting to me. Have you ever thought about like public persisted queries, Scott?
Yeah, sorry. Yeah, when I mentioned that we thought about persistent queries earlier, it was actually more about I think public than our internal clients. And I think part of that was the opportunity to, I think we've talked about this before, like giving like enticements, like if you persist your queries, you will get benefits from us, like higher rate limits, or maybe we can do some better caching, because like we could, do some analysis on your query and maybe treat it more like differently than just a normal one. So we've definitely thought about that. And I mean, the rate limits are complicated enough. I don't know the actual end like result, but I do think there would be a difference and a benefit, because otherwise, like, I don't know why a third party would really go through the hassle of this extra step if they didn't see some sort of benefit in return.
Right.
I don't know. Because even with just like the free-form documents that we accept, we can still do static analysis on it. And like for our versioning stuff, like we have a dashboard now in our partners application that says like the exact fields that they're using that are deprecated or going away. And that's there for REST, that's there for GraphQL. So things like that, like you still have the ability to do without persistent queries. So I think it does unlock some benefits. I just don't know exactly what they'd be.
Yeah, that's funny because GitHub uses a kind of a similar strategy for REST, where there's kind of an incentive to do something where if you use kind of e tags or like if not modified and you get a 304 back, so like the resource didn't change, we don't cost you a rate limit for that. So it kind of like encourages people to use caching, client-side caching. So yeah, it's kind of an interesting idea for them. And I can totally see that being the same for persistent query. Like if you persist your queries, like your queries cost like half as much or something. And then like there's so many cool things you can do once on the server you have like the client's queries. Like you can do like, I don't know, like version changing. Like if your field changes to something else in the next version, you can like auto upgrade people that didn't upgrade. Like you can have such a cool like client dashboard where you can like change your queries in an admin or something. It's pretty sweet to think about, but yeah.
Now you've got me daydreaming.
Yeah, I can see it. Like it seems like, so in the end it's going to come back where like clients are basically building endpoints and they're sending it to you and they're like, here's my endpoints, basically.
Yeah.
And they're leaving it at.
I swear there's like, I don't know this well enough, but there's like older like enterprise APIs that I swear like let you do that. I don't know. I don't think it's like SOAP or whatever, but some old enterprise companies have that where you can basically build your own like API, and that's effectively what that is. Yeah, it's a like an interesting way of framing it, like building your own endpoint, and that's what it is at that point.
Right, it kind of is. So Scott, thank you so much for coming. We've had a lot of your time already. Do you have anything to plug or anything before we leave?
Anything to plug? I don't
SoundCloud.
think so. SoundCloud? Yeah, no, I definitely don't have a SoundCloud. No, I mean, Yeah, obviously, by the way, the usual plug is Shopify is always hiring. We are remote basically permanently now. So, if you previously weren't in a city that Shopify had an office in, I encourage people to apply because we're always looking for good people, and now there's less restrictions on where they are. And I mean, yeah, we're always also, if people wanted to try out like the Shopify ecosystem and App Store is quite it's a big opportunity if people want to build apps and make money. We have a huge ecosystem now, and it pays a lot of money out to developers. And the more people that do that, the more people use our APIs, and hopefully we get feedback on that and improve things. I mean, other than building APIs to power our own apps, like the reason we do it is to empower our ecosystem because we want partners to build stuff, and like we hope that we design good, useful APIs. And I don't know, we always like hearing about that too. So if there's anyone out there who is a Shopify partner and has any feedback on stuff, we always like to hear about it as well.
That's awesome. I can definitely preach for Scott's team. It's awesome. Shopify is pretty much the coolest GraphQL setup I've seen. So definitely
Nice.
follow. I'll post the links in all the videos and everything. And I'll post your Twitter as well. So yeah, thanks again, Scott. I'm
Awesome.
going to try to switch
Thanks for
over
having
to
us.
another scene now where Scott is not. See if
All
that
right,
works.
see ya.
See if we're Twitch professionals. Looks like it worked.
Whoa.
Nice.
Wow, look at that transition.
That was awesome. That was
Yeah.
really sweet.
It was, yeah, I was glad my AirPods died, but you two did a good job of filling in. Thanks.
Okay, Scott, we're going to drop you from the call now.
All right,
See you later.
Thanks, guys.
Bye, Scott.
We got it.
Nice. Good thing he didn't just like start talking trash. Like takes off his headphones, is like Twitch and GitHub suck. Like
We did it. So yeah, we had a change of schedule, everyone, but we're back to the same schedule as usual next week on Tuesday. I got bit by an insect last week, and I thought it was infected, so
Oh, no.
that's why. But we're back on track. We're not sure of the guest next week. We'll definitely, we have a lot of people lined up, so it should be great. We also have a YouTube now if you want to catch last week's episode with Dan. That was really cool as well. And yeah, thank you so much for listening. Tony, am I forgetting anything?
Well, hopefully you guys picked up on, I don't know, some of the things we think about on a day-to-day basis, and kind of how I think the most interesting thing is like how we're kind of solving the same problem but radically different ways due to like just the on the ground situation. So I think it's always super cool to see, really interesting, and I get a lot out of these talks myself. I have this little notebook that I've been like jotting down ideas as we go.
Nice.
So
Oh yeah, and if anyone has ideas of a guest they'd like to see or a topic or anything, just definitely message us. Twitter's probably best. Let us know who you'd like to see, and we'll try to get them on. So, all right.
or if you'd like to be on the show yourself.
That's true.
Let us know.
Yeah, we're always looking for guests. So as I was mentioning during the show earlier, we're really trying hard to get Eric Wittern from IBM to talk about that paper. Oh yeah, where's Scott's Twitter? Let me see if I can paste that. Yeah, you should follow Scott.
Yeah, Shopify is kind of on a tear.
They really are.
They seem to be doing fantastic. Yeah.
Yeah, and their platform is really great. Like not only their technology, but just like the app ecosystem and everything they have is just amazing.
Mm-hmm.
So, 1 second, I'll post that in the chat soon. All right, so I think that's it for this week. See you all next Tuesday this time, so it's soon. And yeah, it was really fun. See ya, Tony.
Been fun. Yeah. Thanks, Mark.